Hi, math educators. Do you ever wish that you could get your students to go deeper into the math, to really think about the meaning behind the operations and the numbers? Or maybe you want them to develop more fluency with math facts. Maybe your goal is engagement, to have students doing hands-on and collaborative activities. Well, if you have any of these goals, you should watch this next video. Number proofs are a hands-on math activity where instead of asking students for answers, we give them the answer, and then they have to prove whether the answer we've given is true or not. I started using number proofs with my own students because I was finding certain students were very strong with calculation, but they had a hard time applying their understanding to word problems or to create visual models, to explain their thinking. And then I had other students who struggled even with the basic calculations, and a lot of times it was hard to figure out why they were having difficulty, or they had tried to memorize a bunch of math facts and it just wasn't sticking. There are three main benefits to using number proofs with your students. The first is engagement. If you've ever wanted your students to get involved in discussions or to kind of take action and just give them problems to solve, this is a great way to facilitate that. The second benefit is reasoning. When students do this activity, they're going to become more flexible thinkers with mathematics. They're going to get comfortable with things like balancing equation and even with variables, even at the younger grades. I've done this with as low as third grade students, and they can really get some of the deeper concepts. And the third benefit is fluency. This actually grows out of reasoning when students start thinking deeply about the numbers and they start making connections between multiplication and addition, or addition and subtraction, which is what they'll learn in this activity. Then they actually develop fluency with a lot of their basic facts. So let's take a look at a few examples so you can see how number proofs work. So an open number proof starts by giving students an equation, or you can use an inequality as well. What makes it an open number proof is that we have variables, so it's not filled in all with numbers. There's another video on here on doing closed number proofs. I'd recommend, if your students have never done a number proof before, that you watch that video and start with the closed number proofs. But again, this is a great activity even for younger students. So once you give students this equation, there are three things for them to do. First is to prove by calculation. Next is to prove by reasoning. And finally is to determine, is this number sentence always true, sometimes true, or never true? So to prove by calculation, what we're going to do is substitute some number for this variable, and then we're going to calculate what we get out. So let's start with 7. So when I put 7 in for box, I get 3 times 7 equals 7 plus 7 plus 7. And then it's really just one step to simplify that to 21 equals 21. I've gotten an obviously true statement, so I know this equation is true for this value. But let's try another value. Next, I'm going to try box equals 0, because a lot of times 0 is an exception. We know as mathematicians that 0 is a special number. So let's see what happens when we substitute 0 in for box. So I get 3 times 0 equals 0 plus 0 plus 0. So that simplifies to 0 equals 0, an obviously true statement. So now I've shown two examples where this number sentence is true. However, I haven't definitively proved that it's always true, right? In order to prove that it's always true, I would have to try every single number in for box in order to prove it with calculation. So this is where the reasoning comes in. This is a great way to really nudge students into reasoning. Even if they're great at calculation, there's no way they're going to plug every single number in there. But we can look at this and see that 3 times box, or 3 times a number, is equal to that number plus itself plus itself. So the reasoning here is that this is the definition of multiplication, right? To multiply a number by 3 is the same as to add it to itself 3 times. Whatever number I put in there, it could be negative 17, it could be 3,433,000, it could be 27/16. As long as I plug that same number in, it's always going to give me a true statement. So because of reasoning, I've proven that this number sentence is always true. So here you see I have a number proof. This time I'm using a letter variable, so this might be more appropriate for students who are a little older, but you could also use this with younger students as well, just by replacing the X with a box. This is one of my favorite number proofs because it helps students understand the basic meaning of a variable, and there are certain common mistakes that you'll see students make. So for example, let's start with this one, x equals x plus 1. Let's try plugging in x equals 4. So when we substitute 4 for x, we get 4 equals 4 plus 1. So we simplify with one step and we come up with 4 equals 5, which is an obviously false statement. So I just put a line through this, show that it's not true. So I've proven that it's not true for when x equals 4. So I know that this one can't be always true, but I haven't yet proved it's never true. Let's try another number. As I said, 0 always makes a good choice when I'm looking for an exception, so I'll try substituting 0 for x, and I come up with 0 equals 0 plus 1. That gives me 0 equals 1, which is obviously not true. So again, I'm going to put a line through this, and I'm going to say that this is not true for this value. Now, I still haven't proved that it's never true. In theory, right, I might be able to come up with a number. And when you do this with your students, a lot of times I'll see them throwing out like, oh, what about -5? What about 1/2? Which is great that they're trying to think about, is there an exception? Is there a time when I can add a 1 to a number and get the same thing? And eventually some of them will figure out, no, it's impossible. You cannot have a number that's 1 more than itself. Now, one thing that I'll point out that you might see students do is they will plug in 2 different values for x. So a student might come up with 4 equals 3 plus 1, and this makes a great discussion about how when we're in the same equation, in the same number sentence, x has to always have the same value. So that's part of the reason I have them right at the top of their proof. What is our x value? That's a reminder that x has to have the same value at every part in this equation. So we could have just told them beforehand, right, that a number can never be one greater than itself. But it's actually more interesting, I think, for students to go and do this substitution. And they do it, again, some students, they'll do it once and they'll figure it out. Some, they don't have to do it at all. But for other students, doing that plugging in and performing this calculation really deepens their understanding. It helps them to generalize and get an abstract understanding, which is the whole idea of how variables work anyway, that we're generalizing this to be any number. So by plugging in a bunch of numbers, that's a great hands-on way for students to develop that understanding of how variables work. Let's look at one more example. This again is one of my favorite number proofs, partially because it stumps a lot of students. A lot of students will look at this immediately, and especially if they've done the previous one, like 3 times x equals x plus x plus x, or 3 box equals box plus box plus box. They'll look at this and they'll say, no, 3 times the number can't be equal to x plus x. So let's try some substitutions. When x equals 3, we get 3 times 3 equals 3 plus 3. That simplifies to 9 equals 6, which is clearly false. But now if we plug in 0 for x, we get 3 times 0 equals 0 plus 0, which simplifies to 0 equals 0, an obviously true statement. So since we've proven that it's true for one value and not true for another value, we've already proven that this is sometimes true. That's really the only one that you can definitively prove with calculation. If you get one true and one false, we know it's going to be sometimes true. And now for the explanation here, this is sometimes true because 3 times a number is only equal to 2 times a number, or that number plus itself, when that number is equal to 0. You wouldn't necessarily expect that exact wording from your students, but something along those lines would be our proof by reasoning. So that's the basic idea of number proofs, and hopefully you should be able to try out some number proofs with your classes now. But you may wonder if your students are going to be able to do this, if they're not used to doing these hands-on activities. You might wonder, how am I going to know if their answers are right or not, and what to do if they're just off task or they're not self-starting. So those are probably 3 of the most common questions. So let's take those one at a time. If your students are not used to learning through inquiry, learning through hands-on exploration, you're not alone. Most students do take some time to get used to it, so that is one thing to notice, that it probably won't go perfectly the first time. What I would suggest is to start out with number proofs that are simple. Either use closed number proofs, use simple open number proofs, like some of the ones that we showed here are pretty basic. One mistake that I see a lot of teachers make is saying, oh, well, we're working on multiplying negative decimals right now, so I'm going to jump into number proofs with negative decimals. Once they're accustomed to number proofs, that is a great idea. You can use them to introduce new content, but at first start simply because they're learning the algebraic reasoning. And whether you're in elementary school, that's an entire domain, operations and algebraic thinking. Whether you're in middle school, the domain is called expressions and equations, but it's still a big part of the content is to get them accustomed to algebraic reasoning. So by doing some of these activities, even if it's not specifically things that are coming out of the textbook, they're still going to get great value. Now, the next question is, what do you do if you don't know whether a student's response is correct, right? When we're doing proofs by calculation, we should be able to see. And if we can't see, I would just say this is not correct, right? Sometimes they will, they're not going to simplify properly, or they're going across the page. Part of the idea here is for them to work neatly down the page, keep balance in the equation. So, and there's more detail on that in the closed number proof videos about what are we looking for when they do the simplifying, but the proof by reasoning can still be challenging. Sometimes students will write something, you don't understand what they said, or you understand it and you're like, I've never heard it that way. Is that correct or not? So a couple solutions here. One is the sharing and workshopping. So at the end of the lesson, have certain students come up and present what they have done, even if you don't know if it's right or not, right? And then maybe one of their peers will be able to understand. Sometimes another student will understand it and they'll explain it in a way that it makes sense. Or other times it can just be okay to say, that's a really good one. I'm going to think about it, and then you can just take a picture of that one, send it to me, and I'd love to see it, because no matter how many times you do this, you're still going to get some responses you haven't seen before, and that's part of the beauty of this activity. And the third question I get has to do with off-task behavior. So there's two common problems. Either teachers say they give this activity to their students and they just don't self-start. They just kind of sit there staring at the page because they don't know what to do. And the other is that students are fooling around or not taking it seriously. So I think that the two components to addressing off-task behavior are communicating expectations and accountability. So I use a rubric for this. It has 12 or 13 points that I'm looking for broken down into process, product, and presentation. Having those expectations and the accountability to you for grades is important. Finally, that presentation they do at the end, that is also very compelling. So students, a lot of times, even if they're not working hard on this the first time you do it, then at the end of the class, when they get up, and some students are up there giving a very impressive presentation, all their peers get to see it, and then another group comes up and they're not prepared because they've been fooling around the whole time. The next time you do it, you're going to see much better results out of those students. So now, how do you get started with doing number proofs? I'd say the first thing, the most important, is to just do it. Just write some equations, take some equations out of your textbook, put them on a piece of paper, and ask the students to prove them. It's never really going to feel like you're quite ready for it if you haven't done a lot of inquiry learning before, but once you do it, your students are going to enjoy it. You're going to see some interesting results, and they're going to start learning math in a meaningful way. The next thing that you can do, if you like, is to buy a lesson plan. I've prepared a number of these that have complete sets of number sentences that are designed to highlight certain standards aligned concepts, and they include a key. They include graphic organizers that break down where the students do their calculation, where do they do their reasoning. It includes the rubric. You can do your own without needing my lesson plans, but if you want them, they're there. And finally, for more, if you want to go more in depth on number sentences, visit roomtodiscover.com/online. Has links to our blog, has links to our online workshops, has links to connect with an online coach. So thanks for watching, everyone. I hope you found this video valuable and you understand why you would want to use number proofs, and you feel ready to start using number proofs with your students. If you thought this was a good video, like it and let us know in the comments, and don't forget to subscribe to our channel.